welcome to another video. Today we're going to be explaining cyclopropanation of alkenes. So this is on the exam, it's going to be looking like CH2I2 over zinc copper, or it's going to be a CH halogen slash OH. I'll go over that mechanism after this one. But let's go over this mechanism that's on the screen right now. So it's just going to be a normal double bond right here, and basically what's going to happen is it's going to open up and make a cyclopropyl, that little triangle, and with hydrogens attached to it. And so the other one is just going to be the same thing, except the two halogens are going to be attached to it. But let's go over this mechanism first. So basically what this is, you have an iodine attached to zinc, which is attached to a carbon, and that carbon has two hydrogens as well as the other iodine. So that's what you're going to see here. And so imagine we have our alkene right here with the double bond. What's going to happen is that this bond is going to get kicked off, and it's going to go, those electrons are going to go to the iodine. And for the zinc, we're going to move this bond over here to this carbon, and this double bond right here, we're going to move that over to that carbon because it just lost that bond with iodine. We want to make another bond with it, and we're going to use that double bond. So what we're going to get here is that's going to be to the carbon, also there, that bond, and then now it's going to have two hydrogens. And so it's really as simple as that. You just have to know that how to make this. It's going to be this carbon attached to two hydrogens as well as the iodine, and then the zinc and the iodine. Just know how to make that, and then just move these double bonds around. And so yeah, that's the final product for this one. You can honestly just write it as that. That should be fine as well, or that as well. But for the next one, we can do something similar, but it has an extra step. So this is going to be, let me go to my notes just to make sure. This is going to be very similar, except that it's going to have a halogen. So it's going to be CHCl. We're going to do Cl, it can be Br, but we'll do Cl in this example, over OH. And the product for this one is going to be fairly simple. It's going to have that cyclopropyl, but this time it's going to have those two halogens there. So that's kind of how it's going to look like. Let's go over the mechanism for it. So you have this double bond here, and you have a carbon attached to 3 Cls attached to a hydrogen. And what's going to happen here is that there's going to be an OH floating around, and it's going to grab onto that hydrogen, right? And this bond is going to get kicked out to the hydrogen. And also an important factor here is that one of these chlorines is going to get super excited that they're actually going to leave. One of them is going to leave. So it's kind of different than how we usually do these things. But one of those chlorines is actually going to leave. So it's actually going to be a carbon attached to two chlorines now. And obviously that hydrogen left. So it's just carbon, two chlorines, and we have that bond is going to go over there. And so chlorine is going to leave, but we want these electrons to be transferred to that carbon, not to the chlorine. Sorry about that. So it's going to be now chlorine attached to a carbon right here with one pair of electrons. It's obviously missing one. You're going to see what's going to happen now. So I'm going to move this over down here, and we'll go over it again. So what's going to happen here is these electrons are going to move to one side of the carbon, and this double bond is going to move to this carbon, and it's going to be attached to this carbon here to give you that to the carbon, this bond from the double bond, and obviously two Cls. Let me color code it so you know which electrons are going where. Hopefully that kind of makes sense. Sorry for the confusion earlier, but just know that we have the double bond. That double bond is going to attach to the carbon, and the lone pair from that carbon is going to be attached to this carbon right here. And it makes that cyclopropyl. The only difference from the last mechanism is that now we have two Cl's attached instead of hydrogens. So it's going to just look like this. And I'm doing a dash and a wedge because they're on the same carbon, so you can't have two wedges or two dashes on the same carbon. So it's going to look like that. I think the only thing to really understand here is that this chlorine is not going to stay with that carbon. One of the chlorines are going to leave and give those electrons away to that carbon to give you that weird carbon which has not an octet. It has 1, 2, 3, 4, 5, 6 electrons instead of 8. So yeah, that's basically the mechanism. I hope you learned something.